Hey everyone, and welcome to the Retro channel, and today we are checking out a console that I know practically zero about, but I have heard good things. This is the Colecovision, a console that was released in 1982 and is apparently a pretty decent step up from something like the Atari 2600 or the Intellivision. So I've never played with one of these before. I didn't know anyone back in the day who had one, so I am kind of curious to check this thing out and see what the games are like with this thing. I do have a number of cartridges here, which definitely helps, but I don't know if this thing actually works or if I can actually get a decent video output from it, because the only current option is RF, and ideally I'd like to get at least composite video out of this thing so that I can hook it up to a more modern display or a capture device of some kind. So we're going to put this thing aside just for the moment, because before we get into any of that, we need to check out this power supply. So I guess this is the Colecovision Australian power supply. Obviously, different regions are going to have different looking power supplies. What's kind of funny about this is it looks very similar to some of the Commodore 64 power supplies that were also released here. And not only that, but also some of the Atari power supplies. This is for the Atari 8-bit computer range. So I guess there was a power supply maker that was happy to make any kind of power supply you wanted, and the only real difference here is some of the output voltages. So the ColecoVision in particular has plus and minus 5 volts and also plus 12 volts. I think that's due to the DRAM used in the ColecoVision. I think it has 16K of video RAM and 1K of system RAM, and I guess it's the type that requires these 3 voltage rails. So as you can probably guess, I do not know the history of this particular machine. It may be that it just works. Maybe that there's something terribly wrong with it. It was an eBay pickup with a bunch of other things, I think, and it's been sitting around here for the past couple of years waiting for me to actually play with it. So I figure now's the best time. Okay, with all those plugs untangled, I think we're safe to plug it in. I don't know what's going on with this heat shrink here. It is a bit of a worry that it's on the main side of the power supply, so I'm hoping there's no shorts there. Let's just plug it in, see if it goes bang. Didn't go bang. So pin 4 is common, and pin 1 should have 5 volts. Yep, 5.124 looks good. Pin 2 minus 5, wow, spot on. And pin 3 plus 12, 12.2. That looks pretty good. Obviously there's no load on this thing, so it could misbehave once we actually put a load on it. But initial signs look pretty good. So let me grab a display with an RF tuner and we'll plug it all in and see if it works. Right, everything's hooked up. I'm not going to throw a cartridge in just yet because I know this does have a BIOS ROM in there, so I think it should produce some kind of picture even without a cartridge inserted. So let's power on. And I don't think there's any power LEDs or lights on this thing to indicate that it's on, so I assume it's currently on, and we probably need to retune the TV. We'll try the auto program. I'm not in the UK, but that's close enough, I think. That might have been something. Okay, well that was fairly useless. Well, I thought this might have been it, but if I power this thing off, it doesn't change anything. So I guess we'll throw in a cartridge just in case. Let's go with this one. I might just give the contacts clean first with a little bit of IPA. Oh yeah, they're pretty bad. Might also throw some contact cleaner lubricant on those contacts just to clean up this cartridge and also hopefully clean up the contacts inside the console itself. Give it a bit of that. Let's try again. Alright, so still no change on screen. I'm going to do another channel search just to make sure. And if that fails, I guess we'll open this thing up and poke around on the inside. I mean, I was going to open it up anyway, and part of me was kind of hoping that, it would be broken. So I'm not exactly disappointed by this outcome. And once again, we got absolutely nothing. So let's crack this thing open, see what's going on the inside. Could still be that this power supply is just failing under load. Could be something wrong in here. I guess we're going to find out. Right, so probably should remove this controller, and yes, I'm missing the second controller, which is a shame, and looks like these have a regular DB9 that plugs into the console underneath this plastic cover here. So these controllers normally just plug in under here, and I guess you can sort of hide the cable under there and stow your controller away, sort of. You get the idea. And yeah, odd kind of controller, kind of like the Intellivision or the Atari 5200. The joystick, or the giant thumbstick, it's kind of, it doesn't actually feel all that bad. It's got a good springiness and a bit of resistance to it. And from what I can see, no stick drift, even after 40-something years. So take that, modern consoles. Looks like we're already missing one screw there, so that's never a good sign. Looks like the rest of them are still installed. Oh, and they did give a nice click, so maybe this thing hasn't been opened. Maybe there's no screw normally in that hole? I don't know. Certainly looks like where you'd put a screw. Not all of them are clicky. Missing another screw there. So, yeah. I'm sure somebody has been in here sometime in its history. That serial number's just got one too many zeros in there. That's a shame. Okay, well, I've got 6 out of 8 screws. Now, how does the rest of this thing up? Okay, it feels like the back wants to lift up, but it's still being held in at the front, probably around this expansion module interface thing. We'll talk about that a little bit more later on. Right, well, the rear wants to open up, but something's holding it around the front. Okay, yeah, it's coming apart here, so thinking there's just a clip or two holding it back. Oh, there we go. Is this going to lift off? Yeah. Oh, those controller bays take up a lot of room. This console could be half the size that it is. Okay, reset button, power switch thing. There's our RF tuner mounted over here for some reason. It's interesting. I wonder if this is a PAL only thing and the NTSC versions have an RF tuner in this sort of cutout. Let me know in the comments. So, looks like we need to get this RF shield out of the way, and I can see there is one screw that is all cocked up and cammed out, so that should be fun to get out. I have to just try and get the pliers to grab it. And we've got this grounding strap, so let's desolder that. Just going to get a bit of fresh solder just to try and get everything flowing, because this is going to suck away a lot of heat. It's a very small tip on my soldering iron, but it got there in the end. Alright, any more screws? There is a bit of tape here that's holding some of these wires, but that's fine. And a little cable grommet. Okay, so we've got a Z80 CPU, a little bit of logic here and there. This looks like a ROM. It says TMS 4764. These look like RAM. I'm guessing just the system RAM. They are UPD 2114s. I think they're SRAM chips, but yeah, I'm pretty sure they make up 1K in total. A bit more logic. And moving over here, I think underneath this heatsink is the TMS 9928 or 9929. I don't know. It's the video chip used in this console and also similar ones like the SG-1000 and the SC-3000, and a couple of other things that I can't remember off the top of my head. But yeah, fairly common video chip for early 80s stuff. And yeah, I guess they decided to put a heatsink on top because it probably gets quite toasty. And behind that, it looks like we have our 16K, I think it is, of video RAM. And these are MM5290Ns. So I'm not sure if they're the same as the more common 4116 DRAMs, which use the 3 different voltage rails, but we'll figure that out soon enough. And apart from that, there's a bit more logic, and that's kind of about it. So let's plug this back in again, and we'll see if we can find some voltages on this DRAM. And yes, just looking up the datasheet for the MM5290 DRAM, 16 kilobit DRAM. So it looks like the pinout is the same as a 4116. So pin 16 is ground, pin 9 is 5 volts, pin 8 is 12 volts, and pin 1 is minus 5 volts. I'm just going to turn this thing around so it's not all upside down. Let's power this thing on and see if we can find these voltages. So pin 16 should be ground, pin 1 should be minus 5, and we're seeing, oh, I think I just had a bad connection there. Minus 5.3, that's fine. The negative voltage rail doesn't need to be that well regulated. Pin 8 should be plus 12, and yeah, once again, a little bit under 12, but that's fine for the plus 12 rail. And on our 5 volt rail, we're only seeing 4.4, which is a little bit too low, I think. So yeah, that could definitely be a problem. I think a good idea would be to get a bit of contact cleaner in this power plug and just do a bit of in, out, in, out. All right, let's just check that again. Oh, that's better. 4.81 volts. That's probably enough to have a functional system. Let's just quickly hook it up to the TV again, just to see if by some chance it's actually outputting a video signal now. Right, is it going to find something? Ooh. That looks a lot more promising. Definitely don't remember seeing that black screen when I first tried to tune this thing in. At least not in the very first, channel 1 or 2 or something. Probably channel 2. Okay. Power it off. Yes, that is definitely it. So when I power it on, we get a black screen, which may be normal. It still doesn't seem to be tuned quite right, but let's throw in a cartridge. See if we have any better luck. Still getting nothing. Just going to check those voltages with a cartridge installed, just in case. Let's do a different RAM chip as well. So minus 5 looks good. Plus 12 looks fine. And the 5 volt has dropped a little bit, 4.75. If only I could just I'm gonna clip that onto a convenient ground so I've got a free hand. So yeah, 4.76, 4.83. Could be that the power switch could also use a clean. And it's, I don't know if I can get to those contacts. It looks like they can be accessed from the side, so I'm going to spray in that corner. A little bit in that way. I'll just unplug this and give this a bit of an exercise. Let's see if that made our 5 volts a bit more stable. 4.74. Still about the same, but yeah, it does seem to change a little bit each time I power it on and off. Oh yeah, just tweaking the switch a little bit does make the voltage jump around. So I think we might have to disassemble this and give it a proper clean, because it could just be that yeah, we're not getting enough power through that switch, and that could be causing all kinds of random issues. So let's deal with that first. All right, I have just spotted there's another screw back here, so let's get that out of the way. And is that enough to take this board out? I think so. Big chunky RF shield on the bottom as well. Ew. So some definite signs of rework on this thing. It's possible some of these joints like this crazy inductor looking thing here. Might have just been hand soldered, but yeah, definitely the DRAM, I wouldn't expect them to be hand soldering those kind of things. So, work has been done, which is never a good sign. I still think we should tackle this power switch first, so let's take it off the board and see if we can get it disassembled. Oop, there it goes. Okay, so to get this apart, looks like we just need to squeeze in these tabs on the side. That should release this little PCB. Yeah, not the greatest looking contacts in there. They could definitely use a cleanup. We'll start with a bit of IPA, which is already working wonders. And a bit for these guys, which also want to spring out, okay. Just as long as I know which way to put them back in, that's fine. Just going to give it a very gentle going over with the fiberglass pen. Try not to get fibers stuck in my fingers because that friggin' hurts. Another quick rinse with IPA. Stick these back in here. And to top it all off, just a bit more contact cleaner and lubricant, because this obviously lubricates as well. Cleans and protects, as you might say. And then, with any luck, I'll just drop back in. And we just need to open up those tabs to hold the board in place. It's tricky because you can't push down on the switch itself, and you also can't put too much pressure on these because like dig into your fingers. Also don't want to stab yourself with the screwdriver. Okay, that's mostly held in place. It's still a little bit loose, but once we solder all this back down to the board, that's going to hold it pretty solid. Okay, let's check these voltages again. So hopefully we've got, oh yeah, 4.95 volts. That looks a lot more like it. So yeah, 4.95 volts. And it seems pretty consistent. And yeah, tweaking the switch doesn't change anything. Let's throw a cartridge in again. Yeah, 4.94. I'd say the power supply is working just fine. Let's just double check our 12 volts. Oh, that's now pretty much spot on 12 volts as well. And -5 is also pretty much spot on -5. So yeah, definitely worth cleaning that power switch. So the question is, will we get anything other than a black screen? I guess I did ask for it. Just in case, we probably should try it without the cartridge again. Just a black screen. I don't know if something would normally show up without a cartridge. Let's try Donkey Kong, which I think actually came bundled with these systems, so that definitely helped it sell from what I hear. No. Alright, I think it's time to get the oscilloscope out and just hunt around for a video signal, a composite video signal, and just make sure that it's not an issue with this TV tuner. Alright, let's have a poke around. We've still got a black screen and I don't have a cartridge in, but hopefully we might be able to find just a composite looking video signal. In fact, that looks like a composite looking video signal. Maybe. Is it? I don't know. Let's have a look on the other wires going to this board. That looks like 12 volts or something. That looks like it could be a chroma signal. Is it? Maybe not. Maybe that's just noise. That's the noise signal. But this red wire, I think it was the red wire. Nah, that's not a composite video signal. It's sort of like one, but there's almost like two sync pulses, which doesn't make sense. All right, let's have a quick look around the Z80 just to make sure it's not stuck in reset or something. Why doesn't this have pin numbers? Pin 26 is reset and it's active low, so it should be high at the moment. 21, 22, 3, 4, 25. It's pin 26 and yeah, it's got to be high. Seems pretty normal. And yeah, reset button pulls it low, so yep, that all seems to be working normally. Let's check clock on the CPU, which looks like pin 6. 1, 2, 3, 4, 5, 6. There's definitely something there. 3.57 megahertz, I'm pretty sure that's correct. Maybe we should have a look with the thermal cam just to make sure something's not getting crazy hot. Although the voltage rails look good, so it's not like something's dragging them down, but there still could be an issue somewhere. Especially these RAM chips, being that they use the 3 different voltage rails. Let's see what the thermal cam says. Yeah. They're all fairly warm, about 50 degrees is the hottest one, but the coolest one isn't that far off, I don't think, so that all seems pretty normal. And looking around the rest of the board, yeah, 42 degrees. It's interesting that this is 42 degrees and the one right next to it, which is the same type of chip, is barely warm at all. The chip next to it is 36, so it's actually not that much different. Yeah, nothing here is cooking. The Z80 is about 42 degrees. Some of this logic back here, 39, probably fine. RAM hasn't really changed. In terms of the thermals, nothing's really jumping out at me. So let's continue scoping. I think we'll may as well unplug this, so we're not getting a video output anyway. At least not a useful one. Let's poke around at the RAM just to see if there's any obvious issues around here. Right, so I've thrown a cartridge back in. Let's just poke around at the RAM. So pin 1 is our -5 volts. That's fine. We know that's there. Pin 2 is data in, and yeah, there is what looks like fairly normal activity. Pin 3 is just high. That's write enable, which is an active low signal. So it's not trying to write anything to the RAM at the moment, or at least not this RAM chip. Pin 4 is RAS, that looks fine. Pin 5 is address 0. Pin 6 is address 2, that looks fine. Pin 7 is address 1, that also looks good. It's 12 volts, we know that's there. 5 volts we know is there. Pin 10 is address 5, that looks about the same, as does pin 11, that's address 4. Pin 12 is address 3, also looks pretty normal. Pin 13 is address 6, also looks pretty normal. 14 is data out, looks pretty normal. Like, there's definite activity, it's trying to do something. Pin 15 is CAS, so the only one that looked a bit strange is write enable. I would expect that to be doing something. Let's just power cycle. It seems to just go straight up to 5 volts, or thereabouts. So that could be a problem. Obviously, it's not trying to talk to the RAM at the moment, or at least not the video RAM. Maybe we should check the system RAM. I don't know what the pinout is for these things, so we'll just poke around and see if we spot something out of the ordinary. That's definitely out of the ordinary. 1.5 volts. It looks like pin, I don't know, what is that, 12 or something? 11. Pin 11 is stuck at 1.5 volts. That can't be right, as is pin 12. And 13. So 11, 12, 13 are all stuck around 1.5 volts. I don't think that's correct. Oh, and there's a brief flash of activity when we first power on. Yeah, burst of activity and then 1.5 volts. So yeah, these are 1024 by 4 bits static RAM, so 2 of them would make 1 kilobyte, and 11, 12, and 13 are labeled IO 4, 3, and 2. Data input and output. Yeah, they definitely shouldn't just start floating, although maybe the system is sort of stalling and it's just releasing those lines, and perhaps that's what we're seeing on the scope. Because they could be tri-stated, so maybe if this thing crashes, the CPU just goes, I'm out. I think it's definitely time to look for schematics for the actual ColecoVision. So I did find some schematics on the console mods wiki. Looks like these are modern recreations, so hopefully they're still accurate. I don't know if it's going to fully cover the PAL version of these systems, but should be close enough for what we're doing. And here's our 2114. So yeah, these are connected to some of the data lines. So 4 bits on one of them and 4 bits on the other. Just curious as to where the rest of these go. Right, one of them goes to the BIOS chip. So it could be that there's just nothing happening in the BIOS, and that's why we're just getting a black screen. And could also explain why those data lines just start floating. And the other side is directly connected to the CPU. So I think the Z80 is capable of tri-stating the data lines. So say if the system crashes or it just gets stuck in a weird state, it might be releasing all those data lines, which is why they're just floating around 1.5 volts. That could be what's going on, but I don't know for sure. Maybe we'll check out the halt pin on the Z80, pin 18. Okay, yeah, it's going high and then it's going low and it's still low. And this pin is also active low. So the CPU is currently halted, which means it's not going to do anything. And that's probably why those data lines are just floating. So they're probably also floating on the other RAM chip. Yes, they are. Okay, that all kind of makes sense. The question is, why is the CPU being halted? And poking around at the ROM, it's a similar story. I think all the address lines appear to be doing stuff, but the data lines, or the data bus, all seems to be sitting at that 1.5 volts. So I wonder if there's something wrong with this ROM, because yeah, the legs on it do look pretty rough. This side looks okay, but the other side I can see signs of rust and corrosion. So maybe this ROM chip is bad, and that's why the CPU is, trying to execute code from this, and, something goes wrong along the way, and this thing just halts. And just looking around at the rest of the schematics, just to see what else is directly connected to the data bus. Obviously our ROM, our 2 RAM chips, of course the CPU, and it looks like it comes over to the next page, and U18, oh, that's one of the controller port chips, and U19. Those 2 are also directly connected to the data bus. And that one was getting quite warm. I've just noticed they're different orientations. Is that correct? Yes. According to the silk screen, that is correct. So that one faces that way, this one faces this way. All right, before I go just randomly desoldering chips, I'm just going to have a pause and a little think. Okay, I've had a brief little think. I don't want to think about it too long, that'll take all the fun out of it. But I did manage to find there is a technical manual available on the console mods wiki, so we'll take a look at that in a second. I'm thinking we'll run through the troubleshooting steps in that thing, and also while we're at it, we'll try out this thing, which is the expansion module number 1. This basically allows the ColecoVision to play Atari 2600 cartridges. So I'm kind of wondering if this thing will actually work, obviously with Atari cartridges, because this is basically an Atari 2600, so it's got its own CPU and everything. So it probably bypasses a lot of stuff on the ColecoVision itself, and this is more just used for, outputting the video and audio from this thing. It's possible this thing might actually work, even if there is something very broken on this board. But we'll go through the troubleshooting steps first. So here is the technical manual, and yeah, there's quite a bit to it. Basically goes over, a brief description of the system, this little block diagram, all that kind of jazz, and disassembly, board drawings, parts lists. Somewhere in here is troubleshooting steps. Here we go, little flow chart. So connect game and power, yes, we should. Throw in a game, which we just have to assume works. All right, power on. So we're just getting a black screen. Turn on game, tune TV. Is Colecovision logo on the screen? No. We know the power supply is good, or at least the voltage is good. The coax cable and switch box seems to be okay. It's, we're getting something on the display. It's just a black screen. So go to sheet 2. No picture. No picture. Voltage is good. Yep, we checked all of those. U936 good. I think that means U9 pin 36. Which one is U9? U9 is the TMS video display chip. So I guess pin 36 doesn't actually tell you what it's supposed to be looking like, but sure, let's just see what it looks like. Because it's got this big heatsink on it, I don't actually know where pin 1 is. Alright, that's what I assume is pin 36, and yeah, there's nothing going on there. It could also be that 36 is up at this end. If that's 40, 39, 38, 37. That could be 36. Looks like there's a very small signal there, maybe. Or is it just noise? That's just noise. And if this is 36, 40, 39, 38, 37, 36. Oh, that. Hey, come back. Yeah, the legs on this are pretty crusty as well, so might be that I'm just not making good contact, but that looks like a video signal, or at least sync pulses from a video signal. What frequency that? Yeah, 15.7 kilohertz. That is horizontal sync pulses, and that little blip every so often is the vertical sync pulses. So yeah, it is outputting a video sync signal. It's just there's no video information. It's just sync pulses. So just a black screen like we're seeing. Oh, okay. On the schematics, it's labeled U1, but it's definitely U9 on the board. And yeah, pin 36 is the Y signal, so it should have some kind of brightness information along with those sync pulses, and we're definitely not seeing that. So does that just mean it is a bad TMS video chip, or could there be something else going on? I don't know, it's good and bad. 38 and 35, I'm guessing they're the color difference signals, BY and RY, or B minus Y and R minus Y. And that's what 38 currently looks like. It's almost like an inverted version of 36. And 35, but yeah, all of those point towards a black screen. So I don't think there's a problem with the RF modulator. So let's assume they're not good. So we need to check pins 17 to 24. And so that's pin 17, and not a lot going on there. Nothing on 18, 19, 20. I'm guessing this is just the data bus. 21's high, but that might be 5 volts. 22 is the same. Yeah, there's nothing going on. And 25 is the first pin to have some normal activity on it. Yes, that is the data bus. So yeah, it is directly connected to the rest of the data bus. So of course the CPU is just halted, so it looks the same as all the other pins that we saw earlier. And 25 is the first one with normal activity, and that is the data bus for the video RAM. So I'm starting to get the feeling the TMS chip might actually be okay. It's just, something is causing the CPU to get halted, whether that's just maybe the ROM is spitting out something funky and the CPU is picking up on that. I think there's like a certain opcode that the CPU looks for to, go into the halt state. So maybe the ROM is spitting out something crazy and that's what's causing it. And yeah, just given the pins on the ROM don't look great, then again, neither does the VDP. I'm kind of leaning towards the ROM, and I imagine it's fairly easy to replace this with a regular EEPROM of some sort. So let's remove the ROM. Oh, before we do that, we were going to test this thing, just in case. Alright, I think that is in. Let's throw a 2600 cartridge in here. Let's get some contact cleaner in there. there it is. Okay. So the 2600 or the expansion module does actually work. So while this is sort of running, let's poke around. So yeah, CPU is not halted, but nothing is happening on the system RAM. So yeah, I think everything, almost everything in the actual Colecovision itself is inactive while this is plugged in. Okay, well now we know that it's roughly tuned in. Let's just make sure, just in case. Okay, yeah, definitely a black screen. Let's pull this ROM out. And yes, after a quick look on Google, it does appear that you normally get a boot screen without a cartridge installed. So it's not just that one of these games is bad, there's definitely something else wrong with this thing. So while I wait for the desoldering gun to warm up, I'm just going to do a bit more of an inspection on this board because, yeah, the TMS chip definitely has some crusty legs, so that could still be a problem. But yeah, so does this RAM, and this logic here doesn't look too great. There are quite a few bodges happening in here. It looks like this resistor is bodged over to this one, and there's this craziness here. I'm assuming that's factory. And yeah, as we saw before, there's definitely been some rework done on this board, so who knows what happened there, but apart from the crusty flux everywhere, I don't see any obvious issues. Yeah, definitely the quality of the joints on this board isn't great, so I wonder if these were all touched up at factory. And even after touching them up, it looks like they did a pretty shit job. All right, let's get this ROM out and see if we can test it. All right, that should come straight out. Nice. Yeah, very crusty legs. So hopefully I can read this ROM. It's a TMS 4764NL. So looking at the pinout of the 4764, it looks to be pretty much the same as a 2364 ROM chip. So not one of these, just ignore that. That's the 28-pin version. The 2364 looks like this. So address lines, data, ground, data, address, chip select, blah, blah, blah. Looks to be pretty much the same. So the TL866 or the T48, T56, T101, whatever they want to call it these days, can't natively read one of these 2364 or this 4764 ROM, but you can adapt the pinout and trick it into basically seeing it as a 2764, which the Mini Pro can read. So let me grab the Mini Pro and we'll read this ROM back, see what we get. So in order to use this to read a 24-pin ROM chip, basically what you need to do is build a 2364 to 2764 adapter in reverse. So obviously the 24-pin ROM would go on top of the adapter and you'd have 28 pins coming out the bottom. An easier way, or at least what I'm going to use, is my Neat 2364 programming adapter. So this is what you need to program my Neat 2364, which is basically a 24-pin ROM drop-in replacement, which is reprogrammable. But you can also use this to read back a regular 24-pin ROM. You just need an extra socket on this just to clear those little pogo pins that stick up. And then we can put this on top, making sure all the notches match up, and jump into the XG Pro software, and I've already got it set to a 2864, so we should be able to read this back. I might have to turn off pin detect. Yes, I will, because it's looking for those extra pins that would normally be on a 28-pin ROM, but if we turn off pin detect, we read back a bunch of nothing. That's not a good sign. Let me just make sure this is working as expected, so I'll grab a known working 24-pin ROM, if I could find one. Here's one here. This looks like a C64 revision 2 kernel ROM. So if we throw that in, we should be able to read this back. Yes, okay. The adapter is working. Commodore 64 Basic. So that pretty much confirms that this other ROM is, well, totally dead, or at least totally blank. If it had some kind of internal short, this would probably pick it up, but it seems that it's just got a whole bunch of nothing. So let's see if we can find a ROM for the Colecovision. This was the first search result on Google. I'm assuming this is going to be correct. So download it, open it up in HXD and take a peek. Are there any strings in here? Oh, yep, there's some. Turn game off before inserting cartridge, blah, blah, blah. Yeah, I'm pretty sure that should show up on the startup screen. So that definitely looks like the correct ROM. So once again, this thing is going to come in handy. Just need to remove this extra socket, which is rather tight actually. Surprisingly tight. Stick a new neat 2364 and make sure it's set to programming mode, which it is. We can throw that on there. Throw that in there, and now we can burn this ROM image to the 2364, and we don't have to worry about using a 28-pin EEPROM like one of these things, and one of those 28 to 24-pin ROM adapters. We can burn it straight to here and stick it straight back in the Coleco. Let's load our ROM file in. All looks good. We're already set to 2864, so program. Give it a few seconds. Cool, we are done. Take this back out. Switch it into normal mode. Throw a socket in this thing and stick in our replacement ROM. Alright, socket is in, and I'm pretty sure I put it up the right way. So our replacement ROM needs to match up with the notch on the socket. Let's see what happens. We'll just try it without a cartridge. Oh, it's still a black screen. Let's try it with a cartridge. I really thought that'd be it. Okay, back to the scope. Well, the CPU is not halted. That's good. And yet we've got activity on the data bus, so we've at least done something good. So we solved one issue. There was definitely something wrong with this ROM, but it looks like we still have more faults. So it seems that we've got normal looking activity. Yeah, maybe. Looks fairly normal anyway. So there are a couple of odd little things on the data bus still. There's a little sort of peak up to 1.5 volts there. Maybe that's just the data bus tri-stating. Yeah, that's probably normal. Never mind. Yeah, poking around on the RAM, I don't see anything out of the ordinary. Let's go back to the video RAM, because remember that I think the read-write pin was stuck one way or the other. I think that's pin 3, so it's still just stuck high. So it does appear that, yeah, maybe this TMS chip is actually broken, which would be a real shame, because unlike the ROM, which I can easily replace, don't have any spares of these floating around. I think it's a 9929 in PAL regions and a 9928 for NTSC. Don't quote me on that though. So going back to the flowchart, U9 17 to 24, that's the data bus. That now all looks good. So go to sheet 9, video section. Video section, U9 pin 33 plus 5 volt. I'm not going to switch over to the scope. I'll just relay if there is 5 volts on there. Yes, there is 5 volts on pin 33. Pin 40. Pin 40 looks to have a clock signal on it. Oh yeah, 10.7 megahertz. Again, I'm not going to switch to the scope. That looks fine. Pin 34. Pin 34 is high, so not low. U7 pin 13. I can see U6 and U8. I can't find U7. Oh, here's U7. Okay, U7 pin 13 should be high. And yes, without going back to the scope, pin 13 is just sitting at 5 volts. So U7, check U7, U1, return. What? So that just mean check everything on U7 and U1? Sure, why not? So this is pin 1 on U7, looks fine. Pin 2 looks good. Pin 3, just low. Pin 4, just high. Pin 5, high. Pin 6, low. There's not a lot of activity then. Pin 7, low. Pin 8, high. 9, low. Pin, whatever that is high. Next one's low. Yeah, there's practically nothing going on at U7. I'm sure there should be something happening here, apart from pin 1, which does have activity. Oh, and pin 2. 3. Just power cycling this to see if there's any random bursts of activity. It's pretty quiet around here. Only pins 1 and 2 are doing something. And there's nothing stuck at a silly voltage, but there's also nothing else happening. Okay, on these schematics, U7 is just broken up into the individual gates, so they're probably going to be all over the place. Looks like pins 5 and 6, so this is just a inverting buffer by the looks of it, 74LS05. So whatever comes in on pin 5 should be inverted on pin 6. Let's just see if it's at least performing that function. 1, 2, 3, 4, 5. Again, I won't switch over to the scope, I'll just relay what I see. Pin 5 is high, so pin 6 should be low, and it is. Right, yeah, so it's just a bunch of inverting buffers, 6 of them in total, so let's go through all those on the scope. So pin 1 is the input to one of them, which means pin 2 is the output. And although those kind of look different, I think that's actually normal. It looks like there's a pull-up resistor on the output or something. Or is that the input? Either way, I think those are actually both the inverse of each other, even though they look a little bit different. So if pin 3 is low, pin 4 should be high, which it is. Pin 5's high, pin 6 should be low, which it is. Pin 8's high, which means pin 9 is low. Pin 10 high, so pin 11 should be low. Pin 12 low, so pin 13 should be high. So it's at least performing that function. It's just odd that there's not a lot going on there. I mean, it looks like it's just handling the external inputs for the most part, or at least this one is. Where else does it show up? Here. Oh, okay. External reset and CPU reset. Yeah, okay, so it's just interfacing some of the stuff from the external connector, and the CPU is not being held in reset, so that's fine. What else did it say to check? U1, which is the Z80. Alright, let's do a little tour of that. I'm not going to look up what all the pin functions are, we'll just see if something looks out of the ordinary. That looks normal. Good, 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 fine, cool, cool. Not great. Something is trying to bring it down, but it's only getting down to 1 volt, which, yeah, isn't really a proper logic state. That is pin 1, 2, 3, 4, 5, 6, 7? Yeah, pin 7 is suspect. And pin 21, 22, 23, 24, 25. And pin 27 looks a bit strange. Just goes up to 2 volts and stays there. So 7 and 27. Ooh, that's pretty weird too. That is 38. 7, 27, and 38. Yeah. Okay, 27 is M1. I don't remember what that does. Definitely not a Z80 expert. Oh, 7 is data bit 4. Yeah, okay. That's definitely not right then. What was the other one? 38. 38 is one of the address lines, A8. Also not right. It's so odd that the rest of the address bus and the rest of the data bus looks fine. It's just one of the data lines and one of the address lines that looks off. Yeah, definitely pin 7 shouldn't look like that. That is not a regular signal for a data bus. 27 I'm not sure of because that's M1 and yeah, I don't remember what the function is of that pin. So it's possible it's, maybe that's tri-stated and it's just floating at the moment. So it's just hovering around 2 volts. That's certainly possible. And 38, yeah, an address line shouldn't look like that. So yeah, once again, the data bus is going to go all over the place. I think we can safely rule out the ROM. I didn't really notice that on the RAM, although I was probably looking at the opposing RAM chip that didn't have that data bit on it, or that data line. Pin 14 on U4 should be it. You can't see the scope, but it does look the same on that RAM chip. So something connected to D4 I think is bad. Don't think it's the BIOS ROM because we solved that issue. Could certainly be this RAM chip. And of course it's also got, I think it was A8. Yeah, pin 38 is A8. Obviously that's on this RAM as well. And what else was connected to the data bus directly? Oh yes, these two are connected to the data bus, and the TMS VDP chip is also connected directly to the data bus. I think the easiest option is just to snip pin 14 on U4 and see what happens. It's only a 2114 RAM chip, so they're still relatively easy to come by. And if it turns out that it's not the problem, I can just resolder the snipped leg. So let's give that a try. 13. All right, here we go. Pin 14. I think that's got it, but we'll just check from this leg to pin 7 of the CPU, which is over here somewhere. Yeah. Right. Let's see if that makes any difference. Let's have a look at pin 7. 1, 2, 3, 4, 5, 6, 7. Still doing the same thing, so probably not that RAM. I'll just blob a little solder in there just to reconnect that leg. I'm not sure if the power switch switches all the voltages from the power supply, so I just unplugged it while I was soldering just in case. Let's just make sure this is now reconnected. Yep. Could be one of these. Could be this guy. What else did I say it could be? Could be the Z80. Just going to see what the resistance looks like between pin 7 and ground. So data line 4 and ground, 136 ohms. Seems pretty low. And only 21 ohms to 5 volts. Let's have a look at pin 8, which is one of the other data lines. Yeah, 16k to 5 volts, 16k to ground. So yeah, something is definitely pulling data line 4 pretty hard up to 5 volts. There's only 21 ohms between it and 5 volts. And only 136 between it and ground, which is also strange. Where is that happening though? So it looks like we have 5 volts over on this inductor. So let's have one probe there. We'll have a look at pin 7 on the CPU. 20.6 ohms. Let's have a look from the RAM. 20.6. 20.6 ohms over here. Okay, resistance readings aren't really giving me any clues, so let's continue snipping some pins, I think. Let's go for this guy, because I'm a bit suspect of it, because it was getting fairly hot, or at least hotter than its counterpart. So pin 14 on this thing. Or is it pin 15? D0, D1, D2, D3. Pin 15, I think. And of course it could still be the VDP, but given that these are just 74 LS logic, I'm more comfortable snipping pins on these before I go chopping up the TMS chip. So this pin is getting the snip. No more babies. Yeah, that is definitely disconnected. 1, 2, 3, 4, 5, 6, 7. Huh. It's like the inverse of what it was before. I wonder... It's definitely doing something different, so that's a good sign. I wonder if both of these are bad. Maybe they're supposed to run fairly cool. They were, you know, only a few degrees away from each other, but this one was at 50 degrees. This was at like 46, so both fairly toasty for just standard logic. Yeah, I wonder if this one's bad as well. What's our resistance reading look like now? 1, 2, 3, 4, 5, 6, 7. Pin 7 to 5 volts. Yes, now 9.7K. Pin 7 to ground is 11.3K. Right, let's snip the pin on the other one. It should be around here. That one. Right, this one is also disconnected. Resistance to ground is now 290K. Yeah, that. And resistance to 5 volts is like mega ohms, 20 mega ohms. That seems a lot more like it. Are we going to get a picture? Come on. 1, 2, 3, 4, 5, 6, 7. It's stuck at 2 volts. Seriously? Pin 7. Oh, it was good for a second. So, pin 7, data line 4, now has sometimes normal activity, sometimes it just crashes and does weird stuff, so I think the CPU might still be halting itself. Isn't that pin 18? Yeah, this thing is clearly still not booting correctly. Just in case. Yeah. So I think at this point we know the ROM was bad. I'm pretty sure both of these logic ICs are bad, but they only handle the controller ports, so I don't really have to worry about them right now. And yeah, I think whatever is connected to pin 38 of the CPU, address line 8, something isn't right there, unless it's just not connected to anything at all, and that's just picking up noise from some of the adjacent address lines. And I'm still not sure about pin 27, which is called M1. Just hanging around 2 volts. That could be normal though. So still a lot more work to do on this thing, but I think I'm going to end this one here because no doubt this video has gone on for a very long time. And yeah, we've still got a lot more work to do. So I'm going to wrap this one up here and we'll pick it back up in the next part. Thank you all for watching. A huge thanks to the people that support the channel on Patreon. If you want to do the same, links to that are down in the video description. You'll get ad-free early access to all videos along with discounts on the Electron store, which is where you can find my neat replacement ROM, and of course the programming adapter, so you can read back 24-pin ROMs as well. And yeah, that's going to do it for this one. So if you have any thoughts or suggestions on what I should look at next with this thing, I'm all ears. Please leave it down in the comments. That is it for now. I'll catch you in the next one. Bye.